Yeah, is the screen visible?
Yes, sir.
Now, I think most of you know about this data structure. You have already studied in your CBSE and ICSE board in the computer science subject, but still I will introduce it. What do we have in this lecture? The data management concepts, the data types. There are two types of data, primitive and non-primitive. Then we will look into the types of data structure. There are two types of data structures, linear data structure and non-linear data structure. And then the performance analysis and the measurement of the data structures, and the time analysis of the algorithms, and the space analysis of the algorithms. Now let us look one by one. Now, what is data? Data is the basic fact or entity that is utilized in calculation or manipulation. Now, there are two types of data, the numeric data and the alphanumeric data. Now, when a programmer collects this data for processing, first, what is the need? It is required to be stored in the main memory of the computer. And then after storing it in the main memory, this process is called the representation. How you are storing your data items in the computer memory is called the is this process is called the representation. How you are representing your data. And data to be processed, it before it should be processed, it must be organized in a particular fashion. And this organization, what this leads to the structuring of the data, and hence the we need to study the data structures, how the data is structured or how the data is organized in your computer's main memory so that it can be accessed depending upon the needs of the user, right? Now, what is data structure? Data structure is the representation of the logical relationship which is existing between the individual elements of data, or datum actually. How the individual elements of the data, the relationship exists between them is called the data structure. Or in other words, we can say that it is the way of organizing all the data elements or the data items that considers not only the elements which are stored in it, but also the relationship between them. Okay, we will see the linked list. You have studied array, right? In your first year second sem, I think.
First year, first sem. Yes, so we have studied direct.
Array. It is a way of structuring the data, right? How the data is structured in the array? They are kept in a
Sir, in
continuous
linear way.
in sorry
Sir, the data is kept in a linear way.
linear way in contiguous memory location, right? In contiguous memory location, that is the constant which is involved with the array, and that is also one of the limitation, because you will never find contiguous memory location if you are storing elements after elements of an array and in contiguous homogeneous locations. So it is not possible every time that you will get contiguous locations for storing the array. Okay, so that is one of the limitations of using the array, but it is also a type of structuring your data, because you need to structure data like that. But there is also an advantage of an array. What is the advantage of an array? Anyone?
We can access the elements in constant time.
Very good. the accessing time is very fast because the data are arranged in contiguous locations, so you can access it very fast. But what is the limitation? Limitation is that it. What is the limitation?
We
Random
can,
access is
the
not
operation
possible.
is costly.
Lot of
So we
lot.
can't delete a data very easily.
Yes, for deleting or inserting a data, you to shift. You need to shift the. Uh, if a data is deleted from a particular position, then that position becomes empty, and all the other data should be relocated, which is after that data, right? And also, one of the limitation is the memory space. It wastes a lot of memory space, right? So this is also a type of data structure. Array is also a type of data structure, but we will look into more complex type of data structures like linked list, stack, queue. You have already learned about it, trees. Now we can also define the data structure as a mathematical or logical model of a particular organizations of the data elements. You can also define like that. There are three definitions I have given it. Whatever you like, you can write in your examination. If you can write the first one also, it's the logical relationship between the individual elements. The second one is the organizing all the data elements, and not only considering that how the elements are stored, but also the relationship. And the third one is, it's a, you can say, a mathematical or logical modeling of the of your data items. And data structure, it mainly takes into account the four things, the 4 points. First one is the how you organize your data, the organizations of data, accessing method, how it will how it will be allowed to access your data, or one at a time, or multiple at a time. The degree of associativity, how the data are associated between each other, that is the relationship, mutual relationship between the data items. And how you process alternatives for the information. If you need some information, how would you process? Okay. So the representation of a particular data structure in the memory of the computer is called the storage structure. This you already know. And what is the file structure? The storage structure representation in your auxiliary memory is called the file structure. Suppose this is an algorithm. What is an algorithm? How would you define an algorithm? Anyone?
Sir, an algorithm is a set of rules not actually, sir, but a set of methods which are required to solve a problem.
Yes, very good. So it's a set of rules, or you can say a set of methods, or some iterative steps to solve a particular problem. And if you add your algorithm to the data structure, it will become a program. That how you are structuring your data, and based on which you design an algorithm, and combining these two, you will get a program. Now, how this data structure is classified? Firstly, it is classified into two. Sorry, it is not coming. The first one is the primitive data structure, and the second one is the non-primitive data structure. Now, in the primitive data structure, you are having, what is primitive data structure? Primitive data structure are basic structures which are directly operated upon by the machine instructions, or which are already available for use. They are the basic data structures like integer, float, character, pointers. You have learned this about in your previous semesters. And then comes the non-primitive data structure. What are the non-primitive data structure? These data structures are derived from your primitive data structure. And this non-primitive data structure, it mainly emphasizes on structuring a group of homogeneous or heterogeneous data items. And some examples are array, list, and file. Now I will told primitive data structure, you are having your integer, floating point, character pointers, and your non-primitive you are having your array, list, and files. And again, lists are again divided into two types: linear list and the non-linear list. In the linear list, you are having a stack and queue, and in the non-linear list, you are having your graphs and trees. Right. So we are not concerned about primitive data structure. We will be concerned about this non-primitive ones, mainly the list part, because the array and files are already covered in your previous semesters. So we will be mainly focusing on list part, list, the linear list and the non-linear list in detail in this semester. It is already done. Now, what is an array? You already have given me the definition. It's a fixed size sequence collection of elements of the same data type. That is also one of the constant of the same data type. Data type should be same. And for a list, what is a list? A list is an ordered set which contains the variable number of elements, and it may contain variable data types. That is the flexibility of list. Okay. It may contain different elements of different data types, but an array should contain elements of the same data type. And what is a file? A file is a collection of the logically related information, or it may contain, or we say that it's a set of list, and it can be viewed as a large list of records which may contain various fields, like in database. Have you do you know database? Have you learned database management system, DBMS? Do you have DBMS in your syllabus?
No, sir.
Oh, so it's like a database management system. Suppose you may know that, for example, what can I say? Uh, Suppose I have the a file which contain the records of all the IEE students which are studying currently in the Jadavpur University, the first year, second year, third year, and fourth year. So I may having a file which contains four records, and these four records contains, you understand that a single record may contain various fields, like your name will be an integer, sorry, name will be your string, then your roll number will be an integer. Okay, your address, it is again a string. Okay, your age, okay, your gender. So it is a collection of your logically related information, which is logically related. So it is called a file. So this is an array, this is a list, and this is a file. Now coming on to the linear and non-linear data structure. What do you mean by linear data structure? Sorry. A data structure is said to be linear if its elements are connected in a linear fashion by means of logically or which are in sequence memory locations, like the stacks and queue. Just for a time we know about the stack and queue, we will discuss it later, the stack and queue. And in the non-linear data structure, these are the data structures in which the items are not arranged in a sequence. The examples are tree and graphs. There is a stack. The first figure contains the stack, the push and the pop. I think most of you know stack. Stack means LIFO. Do you know LIFO? Full form of LIFO?
Last in first out.
Last in
Last
first
in
out.
Yes, the element which is inserted at the last will be the first element which will be out. And similarly in Q also, Q is a FIFO. Q follows the FIFO format. The first in first out. The element which is inserted at the first, will be the element will be inserted at the will be deleted first. Okay, and the tree and the graphs, where you can insert and delete elements in a very non-linear fashion. Now, what are the operations which can be performed in the data structure? You can create data elements. It results in reserving your memory, for which you require some memory to be reserved for the data elements. Destroy, you can delete an element, and after deleting it, you should destroy the memory space which is allocated for that specific data element. Selection, that means you can select, you can access a particular data within a data structure. Updation, you can update or modify the data at a particular location in your data structure. You can search, you're searching, it finds the actually the presence of the desired data item in the list of data items. Okay, you're searching for some specific data item. Suppose I say that in your database, I have the database of the students of your IEE second year students, and I want to search for those students only who have got 100%, who have achieved 100% in the data structure subject. So I want to perform, I need to perform some searching method, right, for finding the some desired data items. Similarly, sorting. Suppose I want to sort the data. Suppose I want uh, the names of those students who have achieved, who have achieved the top three, who have came in the top three. Okay, in the previous semester. So you need to sort the your marks in ascending order, and after sorting the marks, I will take the top three. Okay. Next comes the merging. The what do merging? Merging means when you are merging two different kind of data structure. We can merge two arrays. We can merge two linked list. It is a process of combining the data items of two different sorted list into a single sorted list. You have two different sorted list. You have two different lists of students. Suppose the IW students of second year and IW students of third year, and we are merging into a single list based on some criteria. That I want to see the name of the students who have achieved the top five, who are in the top 10. Okay. So this is, we can also perform merging operation, splitting operation. It is a process of partitioning the single list into the multiple list. Suppose I want to split the data for it may be required for multiple. Suppose I want to split a single list which is containing all the names of the database of your IW second year students based on the marks, and based on the marks I want to segregate it. Suppose I want the names of the students who have received 60 to 70%, below 60 to from 60 to 50%, and from below 50%. So I am separating a single list into some multiple list. Traversal, it is a process of visiting each and every node of a list in a systematic manner, one by one. Okay, so these are the operations of the data structures which may be performed on any type of data structure. Now coming on the time and space analysis of the algorithms. Now sometimes what happens, there are more than one way to solve the problem. Okay, we need to learn how to compare the performance of different algorithms and choose the best one to solve a particular problem. Now what happens is that the problem is that there are multiple algorithms which are existing in the literature, and there are also some algorithms which are coming day by day. The day by day algorithms are getting designed, right? So how would you say that which algorithm is the best, or which one is performing better? There are multiple algorithms which are existing, different algorithms. You have also learned in your subject that or you can say that, suppose take a problem of a C program. Suppose I want to insert an element into an array. Okay, insert an element into an array. So for inserting an element into an array, you can write two or three different types of algorithms, right? You may use function. You can also solve that problem by using function. You have designed a function for a function insert, and you can call that function in your main program. Or you can write all the your insertion program in the same program. That is also possible. So how would I say that which algorithm is the best? Now there are two parameters for uh, choosing the best algorithm. First one is the time complexity and the space complexity. By measuring the time complexity and space complexity, we can say that whether an algorithm is good or not good. Now, what is time complexity? Now, time complexity of an algorithm, it actually defines the amount of time which is taken by the algorithm to run as a function of the length of the input. You gave the input, and from at the time when you gave the input till you get the output, the time which is taken by the algorithm defines the time complexity. And what is the space complexity? Complexity use is the amount of space, or the, you can say, memory which is taken by an algorithm from the time where when you have given the input till the time you receive the output. That is the space complexity. Now this time and space complexity actually depends a lot of hardwares, like hardware, which kind of, what kind of hardware you are using, what kind of operating system you are using, what kind of processors do you have. If you have a good processor, a very newly designed processor, so your program will run very fast compared to other processor, right? Now, but the worst part is that we do not consider these factors while analyzing the algorithm. We do not consider this kind of factors. This kind of factors really matters. It really matters when, if you're running a program in a normal i3 computer or your i7 computer, it matters. But we do not consider these factors. We only consider the execution time. Now, how to calculate the time complexity of an algorithm? It is mainly calculated by counting the number of elementary functions which are performed by the algorithm. Now, since the algorithm performance varies with the type of the input data, so for an algorithm, we usually take the worst case time complexity of an algorithm, because that is the maximum time taken for an input size. Okay, with this, what I want to say, when you are giving your design an algorithm, and suppose there is an array of 100 element, okay, and I want to search for a particular element, suppose 5, which is located at the very last, which is the last element, like at index number 99, which is located at index of 99. So it's the worst case. So we will always check with the using the worst case. The input will be given for the worst case to check that what is the maximum time it requires. This is how we measure the time complexity, by considering the worst case. Okay. And completing the time complexity. Suppose this is the a function for the calculating the sum of the elements of a list, or you can say a one dimensional array. You know this function, you have written in the previous semester. Now how would you calculate the time complexity? Now a is an array and n is the number of elements in the array. Now starting from the first line, so it is not visible. For line number 1, I'm just saying the cost is 1. Okay, the line number 1, the cost is 1. Cost is the running time, what time it takes for executing that line. The cost is 1, and the number of times it will iterate is also 1. Okay, and for the second line, see, the cost is 2, and the number of times this loop will run is n plus 1. For the third line, the cost is also 2, since there is a equals to, and there is an addition also, and the number of times it will run is n times. And for the line number 4, the cost is 1, and the number of times it will iterate is also 1, because it is returning. So now how would you calculate cost into number of times? So first 1 into 1 is 1 plus 2. For the second line, the cost is 2, and the number of times is n plus 1. 2 into n plus 1. For line number 3, the cost is 2, and the number of times is n. So 2 into n, 2n. And for the line number 4, 1 into 1, cost is 1, number of times is also 1. So 1 into 1, 1. So after recalculating it, 4n plus 4, it comes to, and the 4 will be neglected as it's a constant. So equals to, it is n. So what is the time complexity of this algorithm? It is the n unit time. So it depends on the number of elements of an array. Whatever be the number of elements of the array, that will be the time complexity of the algorithm. Right? Now, I have mailed the COs, the course outcomes of this subject. For your understanding, I have once again given, there are 5 COs in this subject. For the first CO, we are having just the data structure definitions, the advantages, drawbacks, types, and analysis of the algorithms. For the CO2, we are having the explanation, application, and analysis of the linear and non-linear data structure, which will be coming in the next lecture. The details of the linear and non-linear data structure. In CO3, we are having the different techniques for the searching and sorting, and based on which we will differentiate them in terms of performance, that which searching algorithm or which sorting algorithm is the best, or which one is the optimal, or which one is the worst. And in CO4, we will move on to the OOPS part. That is we will see the basic features of the classes, objects, and encapsulations. And in CO5, finally, we are having just the 3 features: inheritance, polymorphism, and operator overloading. These 3 features of the OOPS, and we will see some programs, some practical programs. Okay, these are the 5 COs. And thank you. Now, is it clear up to here? Any questions?
Sir, in the
Yes.
time complexity, how is was cost calculated?
Cost is calculated based on the what do we say, the number of times it requires for this line to execute. Okay, for example, you can see it like that. For I equals to 0 to n minus 1, so it is equals to, so I equals to 0 to n minus 1. So that is the cost. It is changing times. And also the third line, you see, total equals to total plus AI. So first addition is performed, then it is assignment is performed. So cost is 2. Like this we calculate. I have more examples. I will give it to you, or I have mailed you the ebooks. You can go through it in details. You will get to know in detail. For the class, I've just given a simple example. You can find more details in your book. Okay, go through it, and if you face any problem, you can contact me. Should I stop here, or I can start my second lecture, because we have time? Joydeep?
So we are having time. We can start, sir.
Okay.
Sir, can you send the PPTs to us through mail? Hello, sir.
I think the screen is visible to all.
Yes, sir.
So we have different units in this lecture 2. The first unit belongs to the array. The You all know arrays, but it is required. It is written in the syllabus that you should have an idea of array. So that's why I have given some slides for on the array also. The representation of array, 1D array, 2D array, the applications of the array, and symbol manipulation, like the matrix representation of the polynomial equation, and the sparse matrix is there. I don't know whether you have been taught about this sparse matrix in the previous semester, but it is in there in the syllabus, sparse matrix and its representation. So let us see one by one. 1D array. It is the simplest data structure that makes use of the addresses to locate its element in a 1D form. Okay. And the number of memory locations is sequentially allocated to the vector. The vector size is fixed and it requires a fixed number of memory locations. You can define these memory locations at the beginning, or you can also define at compile time. By using malloc calloc. You know malloc calloc, all these functions for dynamic allocation of the array.
Yes, sir.
Good.
Yes, sir.
Yes. So you know all this. So vector is, suppose it's an array A having I number of elements, and L0 is the address of the first word, or you can say the first element allocated to the vector A, and C is the size of the each element or node. So the address of element AI is the lock A, lock means location of AI equals to L0 plus C into I minus 1. Now let us consider a more general case. The address of element AI is location of AI plus equals to L0 plus C into I minus B. This is the I minus 1. So L0 plus I minus 1 into C. Now the two-dimensional arrays are also called a table or a matrix. They have two subscripts. One is the column, the two-dimensional array in which the elements are stored column by column is called a column measure matrix. And the two-dimensional array consisting of 2 rows and 4 columns. See, it looks like this. And this is the indexing 1, 1, 1, 2, 1, 3. The first one stands for the row and the second one for the column, second indexing. These things you all know that. This is A11, A21, A12, A22, then A13, A23, A14, A24. Now the column measure order matrix, the address of element now in 2D array, the address of the element Aij, that is the location of Aij, is given by L0, that is the lower bound, plus j minus 1 into 2 plus I minus 1 of A2, 3. So L0 plus 3 minus 1 into 2 plus 2 minus 1, that is L0 plus 5. In general, for two-dimensional array consisting of the n rows and m columns, the address element Aij is given by the formula. This is the general formula. Location of Aij equals to L0 plus j minus 1 into n plus I minus 1. The row measure order matrix. This is the two-dimensional array where the elements are stored row by row. It's an n cross m matrix. And here the address element Aij. How would you find? The generalized formula is log of Aij equals to L0 plus I minus 1 into m plus j minus 1. N is the number of rows and m is the number of columns. B1 is the lower bound subscript of the row and U1 is the upper bound subscript. And so how would you find the number of rows? N will be equals to U1 minus B1 plus 1. This you know. Similarly, B2 and U2. B2 is the lower bound of the column and U2 is the upper bound of the column. And how will you find the number of columns? M will be U2 minus B1 plus 1. And the address element, this is the formula. This is the generalized formula. Location of Aij equals to L0 plus I minus B1 into, that is the M is replaced by, see in the previous equation, M is just replaced by the U2 minus B2 plus 1 plus J minus B2 for generalizing this formula. Now what is the applications of the array? The symbol manipulation, that is you can represent your polynomial equation in the form of matrix. And the second one is the sparse matrix. Now we can use the array of different kind of operation in the polynomial equations like addition, subtraction, division, differentiation. And we are also interested in finding the suitable representation for the polynomial so that addition, subtraction, division can be performed in an efficient manner. And arrays can be used to represent the polynomial equations also. See, this is how we can represent the polynomial equation. X square, x cube, x to the 4, y square, y cube, y to the 4. This is how we represent it. See, I have an equation like 2x square plus 5xy plus y square. How would I represent 2x square, 5xy plus y square, right? Similarly, for the, I have equation like polynomial equation like x square plus 3xy plus y square plus y minus x. So how would I represent x square 3xy plus y square plus y and minus x. This is how you can represent the polynomial equation in the form of a matrix. Now coming on to the sparse matrix. Do you know about the sparse matrix?
No, sir.
No, sir.
So this will be new.
No, sir.
Now what is a sparse matrix? An m cross n matrix is called a sparse matrix if many of its elements are 0. And if it is not sparse, it will be a dense matrix. So a matrix can either be sparse, either be a dense. If many of the elements of the matrix are 0, it will be a sparse, and if it is not, then it is a dense matrix. See, you can find this kind of matrix. You have seen this kind of matrix where, see, most of the rows and columns values are 0. This is a 4 cross 8 matrix, and see, most of the elements are 0. So this is called a sparse matrix. Now we can arrange this kind of sparse matrix into a linear representation. Why? Because see, most of the elements are 0. So the rows and columns which are having the elements are 0, we can it is not required to store them, right? See, for the row number 1, column number 4, the value is 2, right? Row number 1, column number 7, the value is 1. Similarly, row number 2, column number 2, value is 6. Now, row number 2, column number 5, value is 7. And similarly, for the row number 2, column number 8, value is 3. Row number 3, column number 4, value is 9. Row number 3, column number 6, value is 8. Row number 4, column number 2, value is 4. And row number 4, column number 3, value is 5. So we can represent this matrix in a linear form. Okay. Now to construct the matrix structure from this linear representation, we need to record. What we need to record? The original rows and columns of each non-zero entry. Okay, that what I have recorded in the previous slide, and the number of rows and columns in the matrix, that is also required, because we have reduced the matrix from the 4 cross 8, we have reduced it. So we need to know the exact number of rows and column if the user demands it for it, because I have reduced it for saving my memory or saving my computer memory, but the user have saved it as a 4 cross 8 matrix, but I have reduced it to save my memory. So each element of the array in which the sparse matrix needs to be mapped. So we require 3 fields. What we have seen, 3 fields: the row value, the row value, the column value, and the element. Now just see. Suppose this is a 6 cross 7 matrix. This is a sparse matrix because most of the elements are 0. Now, how much memory space do we require to store this matrix? 617 matrix. 6 into 7, that is 42. And if I consider an integer value to be of 2 bytes, okay, right now I'm considering each integer value as a 2 byte. So 42 into 2, how much bytes we required? 84 bytes. So 84 bytes will be required for saving this matrix in the memory. Now suppose I represent this matrix into a linear form. Similarly, row number 1, column number 3, value 6, row number 1, row number 2, column number 4, value 7, row number 2, column number 5, value 8, row number 2, column number 7, value is 4, row number 3, value, column number 1, value 10, again row number 4, column number 3, value will be 12, row number 6, column number 4, value will be 3, row number 6, column number 7, value will be 5. So how many space do I require now? How many bytes? Any idea?
60.
Why 60?
$20 bytes.
Why 20? What I have told, for linear representing it, the sparse matrix, we require three three fields: the row,
Oh,
column, and the value. So row হচ্ছে 10, 10টাই রাখছে, column 10টা লাগছে, ভ্যালু 10 লাগছে, তাহলে 10 into 3 30, 30 আর একটা ইন্টিজারে 2 বাইট করে ধরলে 30 into 2 60.
60 bytes.
তাহলে if we represent this sparse matrix into linear form, we require 60 bytes. So how much saved? 24 bytes. So we are saving 24 bytes. Okay, if we are linear representing it. Now we Ankit, please mute yourself. Yes, thank you. Now we require 60 bytes. Is it clear for linear representing it? Because 10 rows, 10 columns, and 10 values. So 10 into 3, 30, and 30 for each integer we require 2 bytes for saving it. So 30 into 2, 60 bytes. So previously we are requiring 84 bytes. Now we require 60 bytes. We save 24 bytes. Now we can reduce it further. How we can reduce it? Just see in the row. In the row we are having 1 1, then 2 2 2 2 2, 3 4 6 6. So there are some repetitions, right? Can you see? It is not in the column. It is not in the column. It is not in the value part. It is mainly in the row part. You see, there are some repetitions. The 1 appears 2 times, 2 appears I think 4 times, and there is no 5, and 6 appears 2 times. So we can further reduce it also. So this was our matrix previously, and see how we can further reduce it. We have written 1 2 3 4 5 6, since we have 6 rows, so there are 6 rows now. Okay, and we are saving the index number of each of the first column. See, the index number of the first column is 1. It is stored as 1. The index number of the column number 3 is 3, actually the third position. So the number 3 value is stored. Similarly, 7 is stored. Then 8 is stored. And at the row number 5, there is no value. So it is 0. And row number 6, starts from the column number 9. So the value 9 is stored. So this we can reduce it. How it is reduced? How much it is reduced? Now the 6 plus 10 plus 10, that is 26, right? 26 into 2, it becomes 42. So
52, sir.
sorry, 52. Okay, so we again saved 8 bytes. So this can be now it cannot be reduced. From this it cannot be reduced. So this is how we can represent a sparse matrix into a linear form. Just keep it for today, and we will start the stack from the next class. Okay. So let me take your attendance. Roll number 1. Roll number 5. Roll 6, 7, 9,
Yes, sir.
9,
Yes, sir.
29, 32, 41,
Yes, sir.
42, 43, 44,
Present, sir.
44. Achha, roll number 6 is
Present.
present. Number 6 is present. Roll number 44 is present. 45, 46, 46 is present. 47,
Present, sir.
yes. Yes, Ankita, I've given present. Roll number 47, 48,
Sir, 47. Sir, 47 is present.
47. Achha, 47 is present. 48,
Present, sir.
49, 50,
Yes, sir. Present, sir.
51,
Yes, sir. Present.
52,
Present, sir.
60,
Yes, sir. Present, sir.
65,
The 61, sir.
61.
Yes, sir, 61.
তোর নাম কি?
The শুদ্ধ সত্য গুহ।
হ্যাঁ, ওটা তো 60 দেখাচ্ছে।
না স্যার, আয়ুষ্মান ব্রহ্ম 60 স্যার।
আইসন নম্বর 60, তাহলে আমার মিস্টেক হয়েছে। হ্যাঁ, মেবি ঠিক আছে। তোমার তো প্রেজেন্ট দিয়েছি, রোল নাম্বারটা গন্ডগোল হয়েছে তাহলে। 65,
আমার তাহলে 60টা দিয়ে দিন, আমি আয়ুষ্মান ব্রহ্ম।
হ্যাঁ আইসন নম্বর দিয়েছি। তাহলে এত গন্ডগোল
সেটা
হলো কি করে? দাঁড়াও এক মিনিট।
স্যার আপনি ইন বিটুইন রোল নাম্বার 45 হয়তো ইনক্লুড করেছেন।
রোল নম্বর 45, হ্যাঁ 45 রিয়ন সামন্ত।
স্যার
ওটা
রিওয়ান
নেই?
46 রোল নাম্বার। রিওয়ান 46 রোল নাম্বার।
ও আচ্ছা, রিয়ন 46।
Sir, roll number 29 present, sir. I was having some mic issues later, earlier.
29 সুবলিন সিং তো?
Yes, sir.
হ্যাঁ হ্যাঁ।
ওকে। দীপন বর্মা 44, তারপরে 46। আচ্ছা, রিয়ন হচ্ছে 46। ওকে
ইয়েস।
ওকে, তাহলে ঠিক আছে। আচ্ছা, 65,
Yes, sir. Present, sir.
অনিকেত। 66,
Present, sir.
68,
Present, sir.
70,
Present, sir.
72, 74,
Present, sir.
75.
Sir, 72, sir. 72, sir.
अच्छा 75
Milad.
present. हाँ ठीक है
Present, sir.
75 present. Okay 76.
Present, sir.
77. 78. 79.
Present, sir.
79. 80. 81.
Yes, sir.
82.
Present, sir.
83.
Yes, sir.
84.
Present, sir.
85 present.
Present, sir.
86.
Present, sir.
87. 88.
Present, sir.
89. 90.
Present, sir.
91.
Present, sir.
92.
Present, sir.
93.
Present, sir.
94.
Present, sir.
95.
Present, sir.
96.
Present, sir.
98. 99. 100.
Present, sir.
101.
Present, sir.
102.
Present, sir.
100 না 2019 বিপ্লব মহাপাত্র নেই আচ্ছা এবার ল্যাটারাল 001 002
Present, sir.
003
Present, sir.
004
Present, sir.
005 Tomol
Present, sir.
Tomol present okay Prosenjit 006 007
Present, sir.
Sir, can you mail us the PPTs that you presented today?
Yes, I will definitely mail you the PPTs. And one thing I want to ask you that I am actually not okay, not feeling okay. I told Joydeep, I don't know whether I have COVID or not, but I am feeling very weak. I am no taste, feeling no taste of the food, what I am having. So, is it required to go? My next slides will be on stacks and all that, stacks and queue and linked list. Please tell me how many of you know about all this about it, because this is all algorithms and these are well-known algorithms. So how many of know about this? Because many of you in the previous year also I have seen that most of students tell me, sir, we all know this about. So how many know about this? Will it be possible so that I can share my slides, and if you feel any problem you can call me. What are your views? Will it be possible? I can share my slides. This lecture 2 overall, the stack queue and the linked list.
Sir, you can share the slides, but the thing is that in our batch, 60% of the students don't know about the data study.
Oh,
They are from
achha.
West Bengal board and many have not started studying DSA.
Oh, that I want to know, that whether most of you know about that or not, because in the previous year 80% of the students know, and 20% those who do not know do not attend any class. So they told me, sir, that we all know this, so what is the need to take the class? You just share us the slide. If something new we will find in your slides, we will contact you, that we are not able to understand. So no problem, I will take the classes. So my next class is, I think, on Monday.
Yes,
Right.
sir.
Monday 2:30 to 4:30, right?
Yes, sir.
So let us fix that. Okay, so let's meet on Monday for the next class from 2:30. Is it okay for everyone?
Yes, sir.
Okay. So let us meet on Monday from 2:30 to 4:30, and I will share the slides. Once I complete this, I will share the slide. Chalo. Bye. Have a good day.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.